Okay, let's start on these that might seem a little bit simpler and then kind of go back to the other ones. How would I solve that one I just started right there? Cassie.
You do +3 and then you do both sides.
Very good. So I'm going to start by drawing my line here, and then just like she said, if this was a -3, I want a +3 to both sides. And that is the step I'm going to show. And we talked in great detail yesterday about how we're building that solid foundation so that as I start to build on this, you don't freak out. You're like, oh, I know exactly what we're doing. Okay, so we add 3 to both sides. These 3's right here are going to cancel out and become one, or not one whole, they'll become 0. This will be b equals, and now I have a -11 plus 3. So remember, every time you are adding and subtracting positives and negatives, you should be thinking about money exchange. So this is, I owe you $11. I only have 3 in my pocket. So what's my balance? What is it? -8. Good, because I still would owe you that money. So it would be -8. Okay, I could always go back and double check this one, because b would be -8 minus 3. Does that equal -11? Yes, it does, and that way I know I did it correctly. Okay, all right, let's try another one that might have been a kind of easy for you. How do I solve that one? Damn. Yeah, divide both sides by what? By 4? -4, good. And why did you choose to divide, Sam? Because it's the opposite of multiplication. Very good. So I'm going to draw my line, and I'm going to divide this side by -4 and this side by -4. Who can tell me why I have to use a -4 and not a +4? Why is that important that it's the same? What is -4 over -4? 1 whole. It's a positive 1 whole, right? If I don't use a negative, then that q stays negative. Does that make sense? Because if I don't, then I'm going to get this instead, which this over this is -1. Does that make sense? Because 2 negatives make a positive. So that's why I have to make sure I always use the same number divided by the same number so that I get 1 q. But I just don't write the 1. Okay, then we do this side. 4 does not go into 52, I don't think, does it? Evenly? So don't we just need to reduce it? What goes into 52 and 4? 2. So how many times does 2 go into 52? I thought I heard 13. More than that, right? What's half of 50? 25. So what's half of 52? 26. So -26. Oh, it does it? 26 over 2? Well, that does go in. How many times does it go in then? So it goes in, okay, that's why you were saying 13. So it goes in 13 times evenly. Looky there. Okay. All right, so now let's get to, how about let's do this one next. Okay, who knows how to do that one? Work our way back to the fraction line. Jenna? No? Okay. Cassie?
You have to times the -7 by -7.
How did you know that I needed to multiply?
Because it's a divide.
Yeah, it's t divided by -7, so the opposite of dividing by -7 would be multiplying by -7. So I want to multiply both sides by a -7. And the -7 needs to be in the numerator, because what happens with those two -7s when they're diagonal from each other like that? They cross cancel. And what's a negative and a negative? A positive. So that's also why we want to use the exact same sign. So this side, all of these cancel, 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 and I'm left with just t. But I also have to multiply it to the other side. So I'm going to multiply this side by -7. And it's in the numerator. So -7 times 7 is -49. And that's what equals t. Okay? If I go back and think about this, this would be right here. This would be -49 over -7. That's how I get a +7 for an answer. So I can double check my work and make sure that it works, and it does. All right, let's try what a lot of you probably thought was the hardest, because anytime there's fractions, you guys freak out a little. How do I do that first one? Kendall. So, okay, technically dividing both sides by a third. You're totally right. That is what I'm going to do. Jenna? Not divide it, but I can multiply it by its reciprocal, which is the same thing Kendall's saying, because when you divide fractions, you do keep change flip, which is its reciprocal. So yes and yes, you're both right. Okay, here's what I would do. I like taking shortcuts. I would just multiply by the reciprocal, because what is this right here? 1 whole, right? Because they all cross cancel. So I multiply this side by 3, or 3 over 1. I don't need it over 1, because I'm just going to multiply. So this all cancels. Oops, I forgot on my line. So P equals what? What's the right hand side? Negative 27. Done. So anytime you have a fraction, just multiply both sides by that reciprocal, and it will cancel out. It's really nice. Gives you that nice shortcut. Okay, any questions on that? Okay.
I have a question on the bottom there.
Okay.
Right?
Yes.
How does it get negative 13?
52 divided by negative 4 is negative 13. It went in evenly. I didn't think it did, but it did. Anything else? All right, so we need to check homework. So have that sheet out. So times 2. Does that make sense if I write it like that? That would be twice A, because if I said A was 10, I said what's twice that? You'd say 20. Okay? And that's my equation. And we're not solving them today. So you don't have to worry about it. We're going to do that tomorrow. You don't even have to worry about solving them. We're just setting them up. I love that digits is just going to let you focus on that part before we try to solve them. Okay? All right, let's look at B. So we've got some new ones in there. What does product mean? Lily. To what type of problem? Addition, not addition. Multiplication. Yeah. So product is multiplication. Okay? And what would increased by be? Something's increased? If I want to increase it. Addition. There you go. All right, and then I see that fancy word. Here's is 7, so we know that we can start our equation there and write equals 7. So I write equals 7. All right, so the product of 2 and a number. I think I'd write product of 2 and a number. You already said product was multiplication. You want to put in? Okay. So 2 and a number, wouldn't that be 2 in? Does that make sense? 2 and a number. And increased by 17, how would I write that? Plus 17. Is that starting to make sense? It's confusing when you first start. This is kind of hard. All right, let's look at the next one. The difference between twice a number 7 and 7 is 17. So what does the word difference mean? Subtraction. Very good. So here's my subtraction. Here again, they're saying twice a number. We should be getting good at this. How do we write twice a number? 2 something. You can use any variable you want. Here's that magic word is. And there's my number 17. Who thinks they can write the equation this time? Sam, you think you got it? Never mind. Micaiah? Kendall?
2 and minus 7.
There you go. 2 in. This time it's going to be minus because it was difference, right? Difference is minus. It says and 7 is 17. All right, let's see if we can decode the last one. 17 less than twice the number is 7. So what is that 17 less than? What operation are we talking about now? Subtraction. Good. Okay, now who thinks they can write an equation now that we've done it over and over again? Zeke? Okay, I love that you said equals 7. That's totally right. I love that you said 2 in. Totally right. And I love that you used the number 17. The only thing we have to be careful about is our order. Okay? So this says 17 less than. Okay? So if an adult and a kid is 17 less than them, how would we have to write that? Okay.
2 and minus 17.
Yeah, does that make sense? If I said you guys are 17 years less than me, you'd have to start with my age and subtract 17. So So minus 17. Okay. All right, let's keep practicing with these types and let's see if we get it. All right, let's try this one. All right, write an equation to represent the following. 8 less than 10 times a number is 36. So if we can decode the words, 8 less than 10 times a number is 36. What should I start with? Rowan. Yeah, is 36. That's where I would start because that's easy, right? So here's is 36 equals 36. Okay, is there any other parts of this that I know? Any other parts? Sam? I'm sorry, what part? Yeah, 10 times a number right here. 10 times a number would be like 10 in. Perfect. Okay, then now let's start to put it together.
There's a less.
There's a less. So what operation would that be?
Subtraction.
Subtraction. Okay, and here's the word 8. All right, how am I going to put it all together, Griffin? Very good. 10 n minus 8 is 36. Very nice. You can say equals 36. Sure you can. All right, let's keep going. All right, so now let's move into the world of transitioning. I mean, in life, we don't usually talk like that, right? I don't say 10 times a number less than this is this. That's just not how we talk. We talk more like this. A photography student wants to buy a digital camera that costs $269.95. She plans to make a down payment of $100 and pay the remainder in 5 equal monthly payments. Write an equation to represent the situation. What is the unknown here? What are we trying to find? The 5 equal payments, because that's what I don't know. So that's going to be your variable, okay? Now, how many times am I going to make that unknown payment? 5 times, right? So right there is like what I just said a second ago. If it was 10 times a number, this is going to be 5 times a number, because we don't know what that number is. So that is going to be our 5 equal payments, so maybe 5p. I'm going to make 5 payments. So if my payments were $10 each, I would say 5 times 10, and that would be 50. Does that make sense? Okay, so then what is the total amount here? Okay, good. So your total amount is what it would say is 17. That's your total. The camera is $269.95. So that's your equals. Okay, so equals $269.95 because that's your total or your is part. Okay, now there's one more number that has to go into this. So think about if you were going to buy something. You gave them some money and then you're going to make payments. So see if this makes sense. You're going to take your 5 monthly payments, 5 times whatever your payments are, because that's what you don't know, plus your $100 down payment, and that's going to equal the total amount of the camera. Does that make sense how that works? Okay, so that's your equation. That's what it would look like. These are very, very equations, big equations we'll work with a lot, because these are called linear equations, so you're going to see this forever, like all the way through 9th grade. You see them a lot. All right, now this next one I think is a little harder. It says an orange grower ships oranges in a box that weighs 10 kilograms each. Okay, each orange weighs 0.2 kilograms. The total weight of the box filled with oranges is 50. I love to start with totals. What does it say up there? What's your total? 50. Do you see it right there? It says is 50. So we know automatically, bingo, bango, that is our equals. Now we just have to figure out how to get that. Okay? So imagine that you have a box filled with oranges and you're going to weigh it. Okay? So does the weight of the box matter? If you're going to weigh it? Yeah, that's going to mean something, right? And then you're going to start putting oranges in. How much do the oranges weigh? 0.2, right? Okay, so your box, this weighs 10. Then I start putting the oranges in. Every orange I put in is 0.2, 0.2, 0.2. So see if this makes sense. Do you know how many oranges you have? So does that become your variable? Yes, and we don't like to use an O for a variable, so I'm going to use something else.